All right, for this last module, I just wanted to introduce you to some of the ways that we actually produce these glass fibers for fiber optics to make these waveguides. Because it's not trivial as you might assume, because we have a glass fiber, but we also have two different refractive indexes in the core and cladding material, and then we also have to have a jacket on it. So these are not trivial materials to make. Okay, so one method for producing these glass fibers is known as the double crucible method. And so, as you might expect, there are two crucibles. One that composes the glass, the glass of the core, and then another crucible that has the glass of the cladding material. And so those two are then basically dropped together such that the core glass is dropped, and then the cladding glass is dropped around it, creating that dual structure that we see and need. All of this again is inside of the crucible. Another method that we can do is we have a rod of the core glass composition inside, and then we put that within a tube, so an open glass tube, and then we heat this glass up, which takes that sort of rod in the tube and shrinks it down into one fused material, so that material is kind of drawn out to give us the proper diameter. And so that's known as the rod and tube method. And then we have the CVD, so chemical vapor deposition method. And this is one of the more common methods that you're going to see. And so in this method, we have a glass tube, and then we actually deposit material on the inside, and then we basically have that preform and draw it down to a fiber, just like the rod and tube method. And so we're going to go over more of these in details. All right, so in all of these methods, we kind of start with the preform, which is a much larger version of the glass fiber with a dual composition, and then we have to draw it out to give us the thin fiber optics that we need. And so all of those require a drawing process. And so this is just one way in which we can do that drawing process. So typically it's fed through the preform's fed here. We have the formation of the preform, and then the diameter here, it goes through a coating material, and then here is the main part where we cure the material, and then we're basically pulling it through these various drums in order to control the speed. And so that's very important. But like I mentioned, the most most important one is CVD. So we'll talk about chemical vapor deposition methods. So these are what first allowed us to get low loss fibers, and this was this information is kind of Corning Glassworks, their process for making CVD. So this gave us losses that are 20 decibels per kilometer, whereas you saw the kind of connection here. So this means that we have only 1% of light after 1 kilometer. So that again, it tells you we have still have quite heavy losses, but this is still considered low losses. Okay, so let's kind of examine this process as well. So we start out with a silica tube. Again, we want to have the highest purity silica tube that we can have. So very high purity silica tube. And this acts as basically a tube furnace, because what we want to do is we have a heater on the outside, and what we want to do is add reactants. So this could be either silica based or germanium, and these are their chlorides, along with oxygen. So those are added in as reactants to the inside of the tube and then heated up. And what they do when they're heated up is those decompose and form oxides, and that leaves a soot on the inside of the tube. And that gives us a deposited glass layer. So essentially, the the oxidation of those reactants with oxygen creates a mixture of silicon and germanium on the surface, on the interior surface of this tube when heated, and deposit glass layer, and we can control the composition by controlling the amount of silicon and germanium that goes into this reactant. And that's rotated as well so that we get a nice uniform layer, and then the exhaust goes out through the other end of the tube. And so this gives us a preform rod where the core is composed of silicon oxide and germanium oxide glass that's been deposited, surrounded by the silicon oxide. And so we can control the refractive index by controlling the composition of silicon and germanium oxides that we add. And so that gives us our preform. And from the preform, we heat up the leading edge of this rod, and that shrinks it down into the fiber of the specific diameter that we need through the CVD process. All right, so let's look at the role that the germanium oxide plays. So it's deposited on the interior of the glass, and that germanium oxide is what's responsible for raising the refractive index. So for every 10 molar percent that we add to pure SiO2, we raise the refractive index N by 0.012. Doesn't sound like a lot, but we don't need a lot of change here. And so that's what gives us the different grades of refractive index fibers in the middle of those fibers. And so that's what gives us these properties that we want in these fiber optics. I put a sort of bonus video here for you in case you'd like to watch it. This is a YouTube video showing the CVD process. So if you'd like to kind of watch more about it, it's a very interesting video kind of showing you what it really looks like when they make these fibers. So it's quite interesting look at that fiber optic process. So if you want to, go ahead and look at that video for that.